Welcome to the quantum era where computing transcends the binary to embrace the uncertain and the infinite. Unfolding before us is a world where zeros and ones give way to a realm of possibilities far beyond our classical understanding. Quantum computing, the prodigy of the technology world, is ready to challenge our preconceptions and redefine our reality. So buckle up because we're about to embark on a fascinating journey. Today, we dive deep into the quantum revolution. At its core, quantum computing represents a radical departure from traditional computing. Let's take a pause and consider what this means. In the world of classical computing, we're dealing with bits. A bit is a fundamental unit of information, traditionally represented as either a 0 or a 1. It's like a tiny switch that can be turned on or off. Now, imagine if each of these switches could be both on and off at the same time. That's where quantum computing comes in. Instead of bits, quantum computers use quantum bits, or qubits. Thanks to a fascinating principle called superposition, these qubits can exist in multiple states simultaneously. Think of it as a dimmer switch that can be any degree of on or off, rather than just the two extremes. But quantum computing isn't just about superposition. There's another key principle at play here, and it's called entanglement. If superposition is the ability of a qubit to be in multiple states at once, entanglement is the ability of two qubits to be linked, no matter how far apart they are. This means that the state of one qubit can immediately affect the state of another, no matter the distance. It's like having two light switches in different rooms, where flipping one also flips the other. These principles, superposition and entanglement, are what give quantum computers their potential for incredible speed and processing power. They allow a quantum computer to perform many calculations simultaneously, rather than sequentially, as in a classical computer. This is particularly useful for tackling complex problems and large data sets where classical computers would struggle, or take an impractical amount of time to solve. But it's not just about speed. Quantum computing also introduces a new layer of complexity and depth to our computing capabilities. It opens up new possibilities for problem solving and data analysis, with the potential to revolutionize fields from cryptography to medicine, from artificial intelligence to climate modeling. So quantum computing is not just a faster version of the computing we know. It's a fundamentally different way of processing information, a shift from binary to a landscape of infinite possibilities. And while we're still in the early days of this technology, the progress made so far is promising. This, combined with entanglement, allows quantum computers to process complex problems at speeds unimaginable to their classical counterparts. We're standing on the brink of a quantum revolution, and the journey has only just begun. The concept of quantum computing has intrigued and challenged scientists for decades. It's a world where the rules of classical physics are left behind, and the strange, often counterintuitive laws of quantum mechanics take hold. In the early 20th century, the likes of Albert Einstein and Niels Bohr were laying the groundwork for quantum theory. They painted a picture of a universe in which particles could be in two places at once and where observing a particle could change its state. Concepts that might sound more at home in a science fiction novel than in a physics textbook. Fast forward to the 1980s, when the term quantum computing was first coined. The idea was proposed that these unusual quantum phenomena could be harnessed to process information in a fundamentally new way. Richard Feynman, the charismatic American physicist, was one of the early pioneers of this idea. He suggested that a machine operating on quantum principles could simulate any quantum system, something that would be impossible for a classical computer. Then in the 1990s, a new chapter began. Theoretical physicist David Deutsch proposed the first quantum algorithm, opening the door for practical applications of quantum computing. This was followed by Peter Shor's creation of a quantum algorithm that could factor large numbers exponentially faster than any classical algorithm, a breakthrough that sent shockwaves through the world of cryptography. In the last couple of decades, quantum computing has moved from the realm of theoretical physics into the realm of engineering. Companies like IBM, Google, and Microsoft are now racing to build the world's first truly useful quantum computer, and the first steps have already been taken. In 2019, Google's quantum computer Sycamore performed a calculation in 200 seconds that they claimed would take the world's fastest supercomputer 10,000 years. Quantum computing has slowly transitioned from fiction to reality. We stand on the precipice of a new era, one where the rules are yet to be written and where the potential of quantum computing is just beginning to be realized. But how does a quantum computer work? The answer lies in the mysterious world of quantum mechanics. A world that is as fascinating as it is complex. Let's peel back the layers and delve into the heart of quantum computing, the qubit. Qubits, or quantum bits, are the basic units of quantum information. Unlike classical bits that exist in clearly defined states of 0 or 1, qubits can exist in a superposition of states. Imagine a spinning coin that's neither heads nor tails but both at once. That's a rough approximation of a qubit in superposition. But the magic of quantum computing doesn't stop there. Qubits also exhibit a property known as entanglement. This means that the state of one qubit can become inextricably linked to another, regardless of the distance between them. Change the state of one, and the other changes instantaneously. Yes, it defies our everyday understanding of the world, but it's one of the key principles that gives quantum computers their power. Now let's talk about quantum gates, the operations that manipulate these qubits. Quantum gates are like the traffic signals of a quantum computer. They guide the behavior of qubits, allowing them to interact and evolve in a controlled manner. They can flip the state of a qubit, entangle two qubits, and more. So, how does all this translate into computing power? Well, the ability to process multiple possibilities at once, thanks to superposition, coupled with the instant communication between qubits, courtesy of entanglement, enables quantum computers to perform complex calculations exponentially faster than classical computers. And the result? Quantum computing holds the potential to tackle problems that are currently out of reach for classical computers. From simulating intricate biological systems to cracking cryptographic codes, quantum computers could accomplish tasks in mere seconds that would take classical computers millennia to crack. As we continue to explore and harness the power of quantum mechanics, we're not just computing, we're redefining the very boundaries of what's possible. Welcome to the world of quantum computing, where the future is being written in qubits and quantum gates. The implications of quantum computing are vast and varied. This isn't just a new way to crunch numbers or process data. No, quantum computing is poised to redefine the fabric of our technological landscape, sparking a revolution that will touch every corner of our society. Let's start with cybersecurity. Today's encryption methods rely on complex mathematical problems that even the fastest classical computers would take centuries to solve. But with quantum computing, these problems could be solved in the blink of an eye, breaking open our current encryption systems and forcing us to rethink how we secure our digital world. But it's not all doom and gloom. Quantum computing also promises to be a boon for scientific research. Take drug discovery, for instance. By simulating the behavior of molecules and proteins at the quantum level, researchers could design more effective drugs, accelerating the pace of medical breakthroughs. And what about climate modeling? Today, our best models can only approximate the complex interactions that drive our planet's climate. But quantum computers, with their ability to process massive amounts of data simultaneously, could provide a more precise understanding of these interactions, helping us to predict and respond to climate change more effectively. The list goes on. From optimizing supply chains to discovering new materials, from advancing artificial intelligence to exploring the mysteries of the universe, the potential applications of quantum computing are as diverse as they are exciting. But perhaps what's most intriguing about quantum computing is not just what it can do, but what it could enable us to become. By pushing the boundaries of what's possible, quantum computing invites us to reimagine our world, to dream bigger, to strive for a future that's brighter, bolder, and more connected. Its potential to change our world is as profound as it is promising. Opening. As we stand on the brink of this quantum leap, the future of quantum computing holds endless possibilities. Quantum computing, in its current form, is just the tip of the iceberg. The real revolution lies in harnessing the full potential of this technology, and that future is being shaped right now. Imagine a world where complex problems that currently take years to solve could be addressed in mere seconds. This is not a distant dream, but a tangible reality within our grasp. Quantum computing is paving the way for such unprecedented breakthroughs. The sheer processing power of quantum computers could revolutionize numerous fields, from artificial intelligence to cryptography, climate prediction to drug discovery. But the journey is not without its challenges. Quantum computing is still in its infancy, and there are hurdles to overcome. Quantum error correction, for instance, is one of the key problems researchers are striving to solve. It's a tricky issue that arises from the very nature of quantum mechanics, where information can be easily lost. But every challenge is an opportunity for innovation. and the brightest minds are on the case. On the hardware front, we're seeing rapid strides. Quantum computers are becoming more stable, more powerful, and more accessible. Companies and research institutions around the globe are racing to build the first universally useful quantum computer, a machine so powerful it could outperform any classical computer on significant real-world problems. Quantum computing is not a question of if, but when. Every day we're getting closer to that tipping point when quantum supremacy becomes the norm rather than the exception. The quantum age is dawning, and it promises to be as transformative as the digital revolution was. Yet, the future of quantum computing is not just about speed or power. It's about seeing the world in a new light, about understanding the very fabric of reality in ways we've never done before. It's about venturing into the unknown, driven by curiosity and the quest for knowledge. Ending. The quantum era is not just coming, it's already here. We're standing at the precipice of a new age, a quantum age, and in this age, the impossible becomes possible, the unimaginable becomes real. Welcome to the future. The quantum revolution is redefining what is possible in technology and beyond. We've delved into the depths of quantum computing, from its fascinating mechanics to its far-reaching implications. As we stand at the cusp of this new era, we invite you to join us on this never-ending journey of discovery. Stay tuned for more insights into the technology that's shaping our world. Share your thoughts on quantum computing in the comments below, and share this video with those who dream of tomorrow today.